All right, good morning, everyone. We are still ahead of schedule, so it's one of those things where we can do a little bit of review and not put ourselves behind. If you are joining the class and you're wondering about the due dates, what do they mean? The due dates are there to help you get the homework done in a timely manner. If for any reason you miss a due date, do the assignment anyways, and then email me, talk to me. We can get you the points from that. But ultimately, I want you to master the skills. I'm not as concerned with the due dates. So now we're going to go on ahead and do a new thing. We're going to go back and revisit in chapter 1. And I'm thinking it would behoove us to look into 1.7 again. I think that this is a concept that a lot of people struggle with. So I'd rather review it too much than not enough. All right, we're just going to give it a moment for the screen to appear and everything to behave. Hopefully it's working and hopefully the recording goes well. So on this, we're going to talk about a couple ideas. So let's start with the idea of what is a perimeter? And when I think about it, I like to think about it in terms of, if I look, here's the word meter. Meters are the standard international unit of measure. Everything in standard international is always measured in meters. So a meter being a length, the perimeter will remind me it's the area around a shape. So if I start at one corner and go, and let me correct that, the distance around the shape. So if I go from one corner back to itself, it's how far do I travel? If I'm building a fence, how much fencing do I need? If I'm putting up, tape around a park to reserve it for a birthday, how much ribbon or tape do I need? Those kind of things are perimeter. It's if I'm around a shape, whatever that shape is, does not matter. If I'm going to cordon it off in any way, it's how much length is involved to it, starting at one point and ending at that point. How much does it take? The perimeter of a quadrilateral, which means quadra being 4, lateral being lines. So if I have 4 lines, the perimeter of a quadrilateral will just be 2L plus 2W. The idea being that we're going to have L here and L here, W here and W here. And multiplication is repeated addition. So I could write this as L plus W plus W is equal to the perimeter. Or 2 L's plus 2 W's is equal to the perimeter. To find the perimeter of different shapes, I can use different formulas, but everything's based on the idea of, hey, how do I find, going around this shape, how do I find how far I go? And the answer will always be by checking out the sides. So if I have the same amount of distance on each side, that would be a square. And so let's call that a side of a square. It's 2 units long and 2 units wide. We could say that's just S plus S plus S plus S. Repeated addition, well, that's multiplication. I have 4 of these. So that's the same as 4 times S. So if all the lengths are the same, I just multiply it by how many sides there are. If the lengths are different, I just add them together. If a few of the lengths are the same, I can use that to add them in groups. When I say perimeter, I'm just talking about if I need to put a fence around it, how much fencing I need to buy. If I'm walking around it, how far did I walk? Now let's talk about the idea of an area. So let's say here, I have this square we're going to do. Okay, so how far is it on this side? It's 1, 2, 3 units. It's also 3 units on here. Now let's say that this is a 3 foot by 3 foot square entryway to a house. So you have the door, and you have 3 feet by 3 feet squared. The person who's having me do some work wants tile. And the tile is 1 foot by 1 foot. How many tiles do I need for that shape? That's a question of area. And the way I know it's an area is because it's measured in 2 directions. It's measured this way and this way. And that's where I'm going to get, okay, each tile is the same as 1 foot squared. That's what that 2 means. That's why we call a number times itself a squared number. Now let's count how many tiles fit inside this shape. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can say 3 times 3 is equal to 9. Here we're talking about how many 1 foot by 1 foot tiles does it take to cover this. When we're covering, we're talking about area. Surface area just means on the surface of it, how much do I need? So when I'm looking at this table, I can look at the top of the table and say, how much surface area does it have? If I'm looking at the carpet, I can look at how much area rug is there. Area means in 2 dimensions. Area means how many equal sized tiles will fit in this shape. So now let's go over the formula for a rectangle. Okay, we'll say it's 2. This side is 4. So the area is equal to the length times the width. If we count it out, 2 times 4, we have 1, 2, 3, 4, 5, 6, 7, 8. So the area is equal to 2 times 4. And we'll do this in feet. And we'll get 8 feet squared. Now I'm going to take just a minute here and I'm going to say, okay, everyone, think about that for a minute. If you're feeling okay with it, great. If your brain itches, you may think about it a little bit more. Look around you, look for tiles in your world. Look for things that you have to calculate areas for, laying sod, things like that. and this will help it click. Now I'm going to do something very rude because I'm assuming that we're starting to get an understanding of how many squares fit in that shape, right? So I'm going to call this side the width, this side the height, but I'm going to change the letters or the length to be rude. Isn't that rude? Why is he changing letters? Oh my goodness. This side I'm going to call H and this side I'm going to call B. I'm going to call B is equal to the base. H is equal to the height. So I'm changing the letters on you. Is that a little weird? Wonder why I would do that. Well, let's play with this shape a little bit, shall we? What is this line doing that I'm drawing here? What just happened? I drew a line. Did I add to it? Did I take away from it? Did I multiply it, making it bigger somehow? Or did I cut it into pieces and divide it? Some might suggest I cut it in half. I divided it by 2. It's from this idea that we get this formula. Okay, I don't know why that one's curved, but okay, whatever. We get the idea that the base times the height divided by 2 is equal to the area of the triangle. So if we have the base times the height divided by 2, that's equal to the area. Now, when we're looking at our definitions of division, we say that in division, it is equal to repeated subtracting or multiplication by the reciprocal. So if I were to say B times H times 1/2, that's multiplying it by the reciprocal of 2. So if you have some A over B, the reciprocal would be B over A. That's what a reciprocal is. So here I have H times B divided by 2. If I multiply that 2, if I flip it across that fraction line, I get 1/2. And this is why sometimes you'll see the area of a triangle with 1/2 base times height. This and this are the same exact thing. This just has multiplication while this one has division. But since division is multiplication by the reciprocal, this is this reciprocal right here. That's why they can turn it to multiplication. If I cut a candy bar in half, how many pieces do we get? We get 2. Because we're cutting it into 2. And I like to think of it when we're cutting it as doing multiplication. Because I'm not taking away from the original, I'm changing its format. So with this in mind, how about we look at these? And I want to start off with one that some people have expressed concern because they're like, hey, Matt, guess what? We don't have the ability to do this one. In the formula sheets that accompanies this lesson, which for some reason is not showing, we have the formula to find this shape's area. This is what we call a trapezoid. So on a trapezoid, here we'll add another page. All right. On a trapezoid, you have two links that come up to two lines that are parallel. And so what we'll do is we'll call this one base 1 and this one base 2. Then we're given a height. If I'm to figure out how long one side of this shape would be, I just want to cut it here and here and try to arrange it so that maybe this triangle then flips over and goes here. I know that's kind of crazy, but it would look something like this. At that point. And so now I've moved that and I've got the same length on both sides. So let's say that my little sister had a nerd rope. You guys familiar with that old candy? Now let's say I had one. And because she's my little sister, you know, I have one that's this long. And she has one that's only 1 unit long. She's my little sister. I don't want to give her my whole candy, but at the same time, you know, she got to be taken care of. You can't ignore your sister. That ain't right. Well, I might come with the idea of, hey, let's add ours together and then we'll cut it in half. So we each have the same amount. Here we need our L's to be the same. So what we do is we say base 1 plus base 2 divided by 2. That's where we're putting them together and cutting in half so we get the same on both. And we're going to multiply that times. Now, if I were to change a few of these, if I change the B's to L's and the H to W, that might be something I recognize as length times width equals the area. Point to the quadrilateral. When I run into a trapezoid, what I can do is I can add the bases together and divide by 2 to find if I turn this into a quadrilateral, how long is that side going to be? And now let's have a look here. This is what we call a composite shape. It's composed of other shapes. We're going to have to do a little bit of thinking. We have this area to, or this length to this length, right? If we go from the bottom to the top, it's 15. Okay. Well, how long is this side right here? If I'm looking at this, how long is that? Huh. Is there a way I can know? Well, if this is a quadrilateral, this side has to equal the same as this side. Otherwise, that just makes no sense. It's not quite a quadrilateral. So by drawing this line here, I'm dividing it into two shapes so that I can figure out what their combined area is. So here I've got the 16 and I've got 11. I can figure out this area real quick. I'm going to know, hey, you know what? That's 16, and we'll say feet on this times 11 feet. By the way, if for any reason you don't label your units, I consider that to be an abomination in mathematics. So just so you know ahead of time. But 16 times 11, well, 16 times 10 would be 160 plus 10 would be, wait, 16 times 10 would be 160 plus 16 would be 176 feet squared. This is why we don't do math in our heads. I almost added an extra 10 instead of an extra 16. Sorry. That's why we do it on paper. See, I do that to illustrate why we don't do math in our heads. But now I need to figure out, hey, what's this length here? Well, if I know this length here is 15, and I know this length here is 11, I'm looking for the difference between the two lengths. And when I hear the word difference, that reminds me I'm subtracting. I'm cutting it to see how it's different. I'm lining them up next to each other and I'm saying, hey, this one's 15, this one's 11. Well, how far is this distance here? That's a weird shape instead of being the arrows I wanted. And so what I'm going to do is say, okay, 15 minus 11, and this is in feet, is equal to 4 feet. Using that, I can now say this is 4 feet tall. Well, what about this base I see, but what about this base? What's its length? Well, when I drew my line here, I'm saying this is a composite shape. This distance to this distance has to be the same for this to be a 90-degree angle, a 90-degree angle, 90 degree, and a 90 degree, which is required. They have to have that sum of 360 to be considered a rectangle or a square. We can't just make up math willy-nilly. If we did, it'd be on bank accounts. So what we're going to do instead is we're going to say, okay, this here is the same as this here. So this is going to be 16. So now I have the base 1 of 8 feet plus base 2 of 16 feet divided by 2 times the height of 4 feet. 16 plus 8 is 24. 24 divided by 2 is 12. 12 times 48. Let's not do math in our heads. I will admonish you over and over again not to do it in your heads. For that reason, we get ahead of ourselves. 48 feet squared. So now I'm going to add 176 feet squared plus 48 feet squared. And this is how I'm going to tackle that. I don't have to overthink it. I don't have to know trigonometry. So if you have that in your toolkit, by all means, feel free to use any method you want. If you want to use, the SOHCAHTOA method to find it out, great, good for you. But you won't need it for this assignment. So if you go to get help and you feel a little frustrated, come talk to me. I'll help you with it. We'll go over it and we'll get you where you're going. Just remember, whatever way it faces, if this line is parallel to this line, and they end up joining with a shorter side and a longer, that's a trapezoid. It doesn't have to be a normal trapezoid. It can be a weirdo trapezoid. That's fine. In math, we love everyone, no matter how weird they are. This one, this is just a quadrilateral. And this one, the same thing, just a quadrilateral. And so on this, we're just going to do our base is here and our height is here. So perimeter, I'm going to add the sides. Area, I'm going to do the base times the height. Any questions, comments, or concerns? All right, this is 1.7. And I am aware that we've already covered some stuff in chapter 2. I'm giving everyone a chance to catch up on testing and things and making sure I have a good recording for the YouTube channel because the last one didn't work out well. Thank you for coming. Yeah, finished.
I consider this space, if I consider this space this high, but not able to consider